My name is Dan Meneley. I'm a nuclear engineer in Ontario, Canada. And I'd like to speak to you today in a way to simplify nuclear engineering, to simplify the process. I'd like to talk about nuclear versus coal, not to make an invidious comparison, but to talk about something that you must find familiar, the burning of coal. And I'll compare that with nuclear production to see that they are really very similar. Nuclear power plants, they all come in very large concrete buildings and nobody can see inside them. And they look very mysterious, but they're not. Most people understand how an ordinary power plant works. It burns coal or oil or natural gas and produces useful electricity. People mine the coal, ship it to the power plant, and prepare the coal for burning. It's then added into a firebox in just the same way as you might burn it in your fireplace. The firebox is just bigger. Air is blown into this firebox, coal is burned, and heat is released. This heat boils water to produce high-pressure steam, to spin a turbine generator. The resulting electricity and out to do all the work that the people wish it to do. Well, a nuclear power plant works in exactly the same way. Heat is released in this thing we call a reactor instead of a firebox. The heat comes from the splitting of uranium atoms instead of from the burning of coal, and we use this heat to make steam. The rest of the power plant is pretty much the same. So why do we use coal or oil or natural gas in one power plant and uranium in another? Many complicated answers to this question. I'll mention only one very simple answer. That answer is cost. Coal, oil, and natural gas is what have produced our beneficial and happy society. And so you can see that it's a complicated process and there will be different answers at different times and different places. There's no simple answer to the cost question, but the answer is crucial to what we do next. There are many additional questions that must also be answered, but I won't bore you with them, I promise. Two real experts in the field of study, named James Conca and Judith Wright, have published an important paper recently on this subject, and following are a few figures from this paper. This figure shows the total cost of producing electricity by 6 different methods. The only exceptions here are the blue and red bars shown for wind and solar. These costs do not include the high cost of providing backup power when wind doesn't blow or when sun doesn't shine. Clearly, nuclear energy is competitive with these other methods, especially if a carbon tax is included. Here we see the measured mortality rate from production of energy, or electricity, by the various methods considered in the Conca and Wright paper. The major producers are shown as tall blue bars on this chart, and their corresponding risk per unit of electricity is shown in the associated red bars. Of all major producers, nuclear energy is one of the least risky options, even including all of the well-known major accidents that have occurred. Unless we change the time scale of our planning, the future energy mix will be determined more by availability of fuel, transportation costs, and societal issues such as siting and financing, and not by how much a particular source costs society in the long run. Are we going to do a short run or are we going to do a long run? If we don't think about the real costs, then fossil fuels will dominate the energy mix at least for the next 200 years. And take your consequences as you choose them. That's what will happen. Thank you very much.